In this video, we're going to refactor an existing program to make some procedures out of what is currently redundant code. Now, the application that we have is a chemistry game where we can show an element. For example, here you see carbon dioxide, and then we can actually show a molecule, carbon dioxide. Then we can take the individual elements, drag them into the box, and this is an oxygen with a carbon attached. You don't see the carbon, but trust me, it's there. And then we can hit guess, and we can see if we're correct or not. And you see in this case, I have dragged in my carbon and oxygen. That's a carbon monoxide is what that is. And it does tell me when I hit guess that I am correct. Now you'll notice if I drag in another element that does not belong, maybe I'll grab, I think we have like a hydrogen or a nitrogen I can grab and drag in. Then I hit guess, it's going to tell me that I'm incorrect because I've added too much hydrogen. There's no hydrogen in carbon dioxide. So the way that we do this is we have a counter for each of the four major elements of life, the CHON elements, carbon, hydrogen, oxygen, nitrogen. As we read a molecule from our answer key database, we iterate around this loop and we increase one for each element that's present in that molecule. Then we take the user's guess and we decrease one for each element that the user put into the box. If it sums up at 0, then we know we've chosen the correct formula. So it works right now, but it's very long, it's very wordy. And so we want to make this a little bit more efficient. And what we're going to do is take these two very similar blocks here, these two for eaches. One is looking over the answer key, the other is looking over what the user has put into the box. And we're going to refactor this into a separate method, or as we call it an AppInventor, a procedure. So what do we need for a procedure? Well, we need a procedure name, and then we need some parameters. The parameters I would pass in are a list, because you see that this for each loop is iterating over a list. And I would also include, are we increasing by 1 or are we decreasing by 1? So we need like a counter parameter. We're going to need to do a little bit of refactoring as well. A procedure is a separate block. So the local variables to this button click event handler will not be available in that block. So we're going to need to change the hydrogen, carbon, oxygen, nitrogen, these local variables. We're going to need to recreate those as globals. So we'll do that in just a moment. Let's get started with the procedure. Now we have a choice to make. If you take a look, there are two types of procedures that we can invoke or that we can create. One does not return anything, it just does some work. The other returns a single value. Now, if this were pure Java, I would do something slightly different because we have the concept of classes and we can return an object. We don't have that option here, at least not yet. So what I'm going to do is I'm going to pick one. I'm going to pick a parameter that does not return a value, because the results of its computation is it's going to change the value of what's going to be our global variables, hydrogen, carbon, oxygen, and nitrogen. So that's why I need to do a bit of refactoring. But nonetheless, let me go ahead and grab this procedure. Okay, and we're going to call this procedure change element count. Something like that will be just fine. I'm going to click on the little settings here, and we're going to need a couple of inputs. Okay, so grab one and grab two. One input is going to be our list of elements. So I'll just call it list of elements. Okay, and the other one is going to be our increase or decrease. So +1 or -1. So I'm going to call that one increment, decrement. Okay, and at this point we have our block set up. Now take a look. If I want to invoke this, let me resize just a moment. Okay, if I want to invoke this, I'm going to go to procedures and notice that there's now a call that wasn't there before. Okay, call change element count, pass in a list of elements, and then an increment decrement operator. So I can take this and I can drop it in place of this block that I'm about to put inside of our procedure. So let me go ahead and make the procedure first. Okay, I know it's going to be a little tricky to get this all on one screen, but I'll do my best. I am going to grab the entire for each. We'll grab our first block. Okay, and let me expand again, give myself a little more space because it's falling off the screen just a bit. Okay, so I want to take this procedure and I want to take this for each block and put it inside the procedure. And actually, it looks like it's grabbing quite a bit, a little bit more than I need. So I'm just going to see if I can separate this off. Might need to get a little tricky with this. There we go. And grab the for each block here and snap. Let me take the rest of the logic and put it back where it was. Okay. Now, let me move the procedure down so that we can look at it in isolation just a moment, because we know we have some refactoring to do. Okay. First of all, it's giving me a lot of warnings because it doesn't know what red molecule is. It doesn't know what set carbon, set hydrogen. It doesn't know what any of these are, because remember, those variables are local variables. They're not visible into a separate procedure. They're only visible within our button guess handler block. Okay, even though the handler block is calling this procedure, the visibility of those variables does not transfer. So let's start by fixing our errors, our big, I don't know if you call them warnings or errors here, but I always say fix those first before you move on. If you don't fix errors and you keep building on them, then you're building on basically a not trustworthy code base, and you're wasting a whole lot of investment. So let's try to get each of these cleared up first. And the first thing that we're going to do is we're going to make carbon, hydrogen, oxygen, nitrogen. We're going to make those global. So I'll simply go to the Variables tab, and I need to make 4 global variables. I'm going to give them the same name because I'm going to get rid of the local variable. So let's see, we will just say initialize global, and we're going to say we want this word here. So hydrogen, carbon, oxygen, and nitrogen. So hydrogen, oxygen, and nitrogen, and carbon. Now, typically, we don't want to overdo it with global variables. So remember, a global variable is one that we can see across several methods, where a local variable is only available within this scope, kind of in this bracket that we see here. If we don't have a reason to make a variable global, keep it local. Part of it is just documentation, because you know a local variable is going to be used in multiple blocks. It means you're going to have to look all around multiple blocks to see where it is used. Where a local variable is only going to be used within that context. So some of it's documentation, some of it is also neatness. If you end up with a lot of global variables, it's kind of hard to tell what does what, and you have to clean things up, and it gets kind of yucky. So I generally prefer locals unless needed. Now we initialize them all to 0, so we're going to do that again. I'm going to Control V. I'm going to just copy this 0 constant, because remember 0 is the starting state for each of these elements, and then we will add to the element when we read in a molecule from the database. We will subtract from that element count when the user puts that element into the little answer key, the answer box. So anyway, I hit my 0 here. I'm going to go ahead and duplicate that 4 times, or actually duplicate it 3 times. So I have a total of 4. 1, 2, 3, there we go. And now we're going to initialize hydrogen to 0, initialize oxygen to 0, initialize nitrogen to 0, and carbon to 0. And now I can go down to my test, and I'm going to say, instead of hydrogen, we're going to say global hydrogen. And you see that now takes care of the little red warning that we had. Instead of hydrogen again, we're going to say global hydrogen. Okay, carbon, we changed to global carbon. And again, global carbon. And oxygen, you see we're knocking these out one at a time. We're making a lot of progress on this. And oxygen. and nitrogen. Okay, and again, nitrogen. Okay, so there we go. Now we still have to change this list. So we're going to call this one list of elements. So just a recap. Red molecule means this is the molecule that we've read from the database. But again, that is a local variable up in our handler up above. So red molecule, READ, red molecule. You see that's a local variable that we're getting from here. We're going to change that to be the parameter. Remember, we have the two different types of parameters, or the two different names that we give parameters. We have the formal parameter, which is the definition of a parameter in a method, and then the actual parameter is the value that we pass in. So our formal parameter here is this thing called list of elements. So I change this to list of elements, and now you see we have satisfied all of those warnings. Okay. Next thing we need to do is we need to change this increment decrement variable here. From a 1, instead of adding 1, we're going to make that a variable so that it can either be adding a positive 1 or adding a negative 1, where adding a negative 1 is essentially subtraction. So increment decrement, I'm going to call this get increment decrement, and I'm going to replace each of these constant 1s with this parameter increment decrement. You see, by taking a constant 1 and replacing it with a parameter, we're making this procedure much more flexible, because instead of only adding 1, this gives us the capability to add or subtract 1. In theory, we could put in any numbers, so we could add 10 if we wanted, something like that. And I'll tell you where that would be handy, is if you look at a carbon ring. So a carbon ring is something we see a lot in organic chemistry. Typically, it's 6 carbons joined together in kind of a hexagon shape. Because this is very common, you see this is, I don't know what this is, hexahydrobenzene. All right, sure, that sounds good. Because this is common in organic chemistry, having 6 hydrogens and then having, 6 carbons, and then having hydrogens pop off of them, a lot of times it can be abbreviated simply with the hexagonal shape. So we could add an image sprite as we make this more complex, which is just that hexagon, which represents 6 carbons. And in that case, when we add the 6 carbons into the answer box, instead of increment or decrementing 1 at a time, we could increment or decrement 6 at a time. As we get into more complex shapes, sugars and things like that, there's even more that we can do. But in any case, by making this a parameter, it's going to make this method quite a bit more flexible. So a little more refactoring that we need to do here. I'll tell you what I'm going to do. I'm going to take, you see I have a whole bunch of nested variables here. I'm going to pop out the initialize read molecule, which is everything except the nested variables. Now, one thing I'll warn you about when you're programming, be quick to clean things up. In other words, if you have duplication, clean up the duplication as fast as possible. So I'm going to go ahead and pop these out because remember, we have replaced the local variables with global variables. So I'm going to pop those out and delete those. Okay. Now I'm going to move back like so. Move everything back into our button click handler. Okay. And now I can refactor some more. So you see here, this is the chunk that we have moved into a separate method. Although actually, no, I'm sorry, it's not. That's the second chunk we've moved into a separate method. One thing I'm going to need to do is I need to call the method that we have just created. So we've created the method called change element count. We need to invoke that. Because if you remember, we used to have a big if-then block up here, kind of neighboring on this one. Now I've taken that, refactored it. In other words, moved it to another method. Now in place of where it used to be, I need to call that method. So I'm going to go to procedures, call change element count, which is our new method, list of elements. Okay, that's going to be the answer key list of elements in this case. And then increment or decrement, we're going to say +1, because what we're doing is we're iterating over a molecule where we know the elements, and we want to say, okay, I'm going to add 1 I'm going to add one element for each element in this list. So, okay, I'm going to pick this guy, and I'm going to snap him right up here. Remember, if you rewind back in the video, that's where the other for each loop is that I've since moved out. Okay, call change element count. What list of elements are we putting in? This read molecule. Just a refresher on that. Red molecule, that comes from our molecule database. That's our database that has the answer key of elements in a molecule. And what we're doing is we're pulling out whatever molecule appears. Well, it looks like my app is closed, but whatever molecule appears on the top of the screen that we're trying to get the user to guess. So this is a list of elements in that molecule. Okay. Now what's our increment decrement? Because this is the answer key, we are going to add 1 each time. Okay. Now here's where things get really good. What we're going to do now is call the method a second time, but this time, instead of calling it with the answer key of elements that make up a molecule, we're going to pass in the elements that the user guessed make up the molecule, which is this for each block right here. Now watch how easy this is. First of all, global molecules, that's what the user has guessed. That is the list of items that are in the little box, the image sprite box where the user is dragging the balls that represent elements. So I need to pull that one aside and save it, but after that I can simply highlight and delete this entire redundant block. And in place of that block, I'm going to make yet another method call to the same procedure that I just created. Only this time it's going to be a little bit different. We're going to pass a different parameter, which is what the user guessed. And our increment decrement is going to be -1 instead of +1. Okay, so let's change this one to -1. Okay, so get the answer key, add 1 element for each element in the answer key. Get the user's guess, subtract 1 element for each element that the user has guessed. That means if the user gets the right answer, we should balance out at 0. If the user adds an element that doesn't belong, then we'll be -1. If the user adds 2 elements, we'll be -2. If the user, if the user forgets to add an element, we'll be at +1 because 1 will have been added from the answer key, but we will not have subtracted 1 from the user's guess. So still works the same way, but you see we've now made this block for our button guess much simpler because we're calling the same code twice with 2 different parameters, but it still works the same way it always has. Just a few more things I need to fix here. Because we have taken away the local variables for oxygen, nitrogen, hydrogen, carbon, I need to change these calls to point to their global counterparts. So global oxygen, global oxygen, global oxygen. Okay, scroll down here then and change our carbons. Okay, global carbon, global carbon, and global carbon. What we had is a shadow situation. Be really, really careful with that. If you have the same variable name used as a local variable and also a global variable, that's what we call a shadow because we actually have 2 variables with the same name. That gets really confusing, and I strongly recommend that we don't do that. Okay, I think we're in good shape now. Let's go ahead, save and deploy and try it out. I'm going to go ahead and pause the video for a moment because that'll take a few minutes, but we'll have a look in just a moment. Now the screen is up and I have hit show new and I have water. Okay, so for that I'm going to want to add a hydrogen and another hydrogen. And there we go. And an oxygen, H2O. And there we go. And now let's guess and make sure that we got the right answer. Oxygen are correct, carbon are correct, hydrogen are correct. So you see that after refactoring, the program still works the same way. It's no different to the user. However, it is a bit cleaner. There's a lot less code in the background. And just to make absolutely sure, let's go ahead and add a carbon, which would be incorrect, and then guess, and let's verify that it shows that our carbons are correct. You've added too much carbon. Sure enough, the game still works as it is. So in this video, we saw how we can take a very long event handler. We can take two major parts out that are very similar and refactor them into a separate method. And the separate method is the one, or procedure if you wish, is the one called change element count. It contains simply one of those two blocks that we removed with just a couple of changes. And those are the parameters that we have used here, the list of elements and the increment decrement. Parameter means, remember there are the two types of parameters that we have, formal and actual. So formal is simply the definition of the parameters, but actual is where procedures get really important because they allow us to pass something in different, and the method will work on those different variables. It will act on those different variables. So what's next? We'll take a look at this. What else? This humongous block that we have, we've reduced it significantly. But take a look at what's going on here. Do you see some redundancy here? Do you see how we have the same block repeated 3 different times, one for each of our elements that we're grading against, hydrogen, carbon, and oxygen? Is there a way that we can refactor this into a procedure? And the answer is yes, although it'll be slightly different because you see what happens is we are accumulating our answers to something called result message. So in our next video, we're going to see how to make a procedure that not only does some work like our current procedure does, but also returns something. And in doing that, we're going to significantly clean up this block here, and we're going to make this block even more manageable. So I'm going to go ahead and save, and we'll see you in the next video. Thank you.